Chapter 4.6, Day 1, Core Concept, the Fundamental Theorem of Algebra. If fx is a polynomial of degree n, where n is greater than 0, then equation fx equals 0 has at least one solution in the set of complex numbers. If fx is a polynomial degree n, where n is greater than 0, then the equation fx has exactly n solution. So for example, if the function is x to the power 3, then you're going to have 3 solutions. And if it's 2, then you're going to have 2 solutions. In this case, fx going to have exactly n solutions, provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3 solutions, and so on. So for example, if you have x minus 3 to the power 2, it means you're going to get x equals 3 2 times. And this is called repeating root, or we call it as repeated 2 solutions. Now we're going to discuss this table below and discuss its degree and number of solutions. For the first equation 2x minus 1, this is a linear equation with degree 1, and number of solution is depends on the degree, so number of solution is going to be 1 as well. For the second one is going to be a quadratic equation because the highest degree is 2. So the degree for this one is going to be 2, and number of solutions are also 2. For next one is 3 because it has the highest degree 3, and number of solutions are also 3. For next equation, x cubed plus x squared minus x minus 1, so degree is 3 and number of solution also 3. The corollary, which is this one, to the fundamental theorem of algebra also means that an nth degree polynomial function f has exactly n0. So if the degree of the polynomial is n, then it's going to have exactly n0. Next, we're going to find the number of solutions or zeros for the equations below. So the next one is, how many solutions does this equation x cubed plus 3x squared plus 16x plus 48 equals 0 have? So its solution depends on the highest degree. So if the highest degree is 3, then the number of solutions are going to be 3. How many number of solutions for this function? Fx equals x to the power 4 plus 6x cubed plus 12x squared plus 8x. That's going to be 4. Now what we're going to do? Now we're going to graph these equations in Desmos, and we're going to notice how many solutions we get. So if this has 4 solutions, that doesn't mean that this equation will cut the x-axis as 4 times. It may cut the x-axis at 2 times, but the other 2 solution could be an imaginary number. If you have imaginary number as solutions, which is a plus ib type, so 3 plus 4i, then it's not going to cut at x-axis. Similarly, x to the power 4 minus 1, if that has all the real solution, then it means this is going to cut at x-axis at 4 times. But if it does have only cut the x-axis at 2 times, means the other 2 solutions are going to be imaginary numbers. So let's figure this out by graphing using the Desmos calculator. Example 2, finding the zeros of polynomial function. Practice. Find all zeros of fx x to the power 5 plus x to the power 3 minus 2x squared minus 12x minus 8. So first thing you want to do is to find all the possible solutions or zeros. So which means that we're going to divide the last number by first number. So last by front. So factors of the last number are 1, 2, plus or minus 4, plus or minus 8, divided by the leading coefficient factor, that is plus or minus 1, plus or minus 1, plus or minus 1, and plus or minus 1. When you divide with 1, you just keep the numbers as it is. So I'm going to use synthetic division to find all the zeros this time. So first we used to do the synthetic division to bring down the polynomial to the second degree. But in this case, I'm going to find all the zeros through the synthetic division. So I'm going to try 1. So let's try 1 here. And you're going to try 1, and you're going to have the coefficient of this is 1, 0, because you're going to plug it in 0 for x to the power 4. And that's going to be 1, 0, 1, negative 2, negative 12, and 8. So for the synthetic division, bring down the 1. So 1 times 1 is 1. So this is going to be 1, 1 again. And then 2 times 1 is 2, 0 here. And then 0 times 1 is 0. So you're going to get here is negative 12. Negative 12 times 1 is negative 12. And you got remainder as negative 20, and this means that x minus 1 is not a factor. So we have to do it again. This time I'm going to use negative 1. So I'm going to use negative 1 here. And that's going to be 1, 0, 1, negative 2, negative 12, and negative 8. Bring down the 1. And you got negative 1 time negative 1 time negative 1 is negative 1. So negative 1 time negative 1 is 1. Add them. 2 times negative 1 is negative 2. Negative 4. Negative 4 times negative 1 is 4. And that's negative 8. Negative 8 times negative 1 is 8. Remainder for this one comes out 0, so it means x plus 1 is a factor. Now I'm going to erase that since you already took notes on this one, and I want to reduce this again. So this become a fourth degree term. So this one is x to the power 4, x to the power negative x to the power 3, 2 to the power x square, negative 4x, negative 8. We're going to use the synthetic division on this one again. I'm going to make a little L again on to this equation. Remember this equation, if I write it in a standard form, it become x to the power 4 because this start from x to the power 5, and this one should start from x to the power 4. I'm going to try another number. I'm going to try negative 1 again on this one and use the synthetic division and see if I get the 0 for this one. Negative 2 times negative 1 is 2, and that's 4. 4 times negative is negative 4. That's negative 8. And I got the 0 this time. So which means that x plus 1 is a factor. And again we got the same factor, so it means x plus 1 is also a factor. X plus 1 is a factor. If I have to write it, I would write it as x plus 1 to the power 2 because x plus 1 is a factor, or twice a factor. Now I'm gonna use this again to solve this, bring it down to the x squared level. So this one is the x cube, negative 2x, negative positive 4x and negative 8. I'm going to use this space, so let's take this one out because this one was not a factor anyway. Now what we have here? We have here is x plus 1 twice a factor, and we have x cubed, negative 2x squared, 4x, and 8. So that's going to be x cubed, negative 2x squared, plus 4x minus 8. So this fifth degree function is reduced into x plus 1 times x plus 1 times x cubed minus 2x squared plus 4x minus 8. So these are the factors already for x plus 1, but we're going to make the factors of this one. I'm going to use here is a grouping method. So for this group, I take x squared out, and inside you have x minus 2. And for this group, I take 4, and you have inside is x minus 2. So the ones I have x plus 1, and then outer would be as one factor, x plus 4. And inner will make another factor, that is x minus 2. So we made the factor or complete factor of this big polynomial x to the 5 plus x cubed minus 2x squared minus 12x minus 8. We found the possible solutions first, and then we have to break this down using synthetic division twice. And I chose the same number because if it happens for negative 1, remainder 0, you can try another time the same factor. So that's why the x plus 1 and x plus 1 was a factor 2 times or twice. And then we made the equation of the last one, that is a quotient actually. And then we solved that by grouping. The complex conjugate theorem. Pairs of complex number of the form a plus bi and a minus bi, where b is not equal to 0. Because if b becomes equal to 0, then this becomes just a, and that's a real number. So if b is not equal to 0, then it's called complex number. So again, pairs of complex numbers of the form a plus bi, a minus bi are called complex conjugates. So when they come in pairs like a plus bi, a minus bi, or 3 plus 4i, comma 3 minus 4i, these are called complex conjugate. If a polynomial function with real coefficients and a plus bi is an imaginary zero of the function, then a minus bi is also a zero of the function. This is exactly the same concept that I was telling you, that if there is a 3 plus 4i is a zero of the function or x value of the function, then there has to be 3 minus 4i. They always come in pair. They do not come alone. If there is a 1 value, if there is 1 with the plus sign, then has to be 1 with the negative sign in the function. Using zeros to write a polynomial function. So we are given with the zeros. Zeros means x value. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and zeros are 2 and 3 plus I. So when you write it in a factor form, if there is 3 plus I, then there has to be 3 minus I in the function because they always come in pair. Okay, If there is a x equals 3 plus I, then there has to be 3 minus I. Always come in twos. The one x value is x equals 2. Other x value is x equals 3 plus I. And then the third one, which is not given, but I assumed, I know that there has to be x equals 3 minus I in the function. So see that here, x equals 2, x equals 3 plus I, and x equals 3 minus I. They're all written in a x value form. We have to write it in a factor form. So we have to write that in x minus 2, which is a factor form, x minus 3 plus I, which is a factor form, x minus 3 minus I, which is a factor form. So if you choose them to write in a factor form, just bring the 2 in the other side with the x. Just bring the 3 plus I on the other side with the x. And just bring the 3 minus I with the other side of x. Now you're going to regroup them. So you're going to write down x minus 2, x minus 3 minus I, because you distribute the negative inside. And then you're going to x minus 3 plus I. This is x minus 3 minus I, and this is x minus 3 plus I. If you bring the negative inside of these factor. Now, if it's saying regroup it, they mean that put the x minus 3 together and read it as a minus b times a plus b. I'm going to apply the method a minus b times a plus b. So that's going to be a square minus b square. So a square minus b square. A square, which is x minus 3 square, means that you're going to find the square of it by writing it to factor and then using the FOIL method. So you use this FOIL method on x minus 3 times x minus 3. You get x squared minus 3x minus 3x plus 9. And you got here is x squared minus 6x plus 9 for this polynomial. You have a 9 and then you have a plus 1 here, so you got this factorization. So x minus 2 times x minus 6x plus 10. Now hopefully you took notes on that, so I can just use this space. So I'm just going to erase that and use this space to find out the multiplication of these two. So with that, I'm going to use a box method, and I'm going to write the top equation, x squared minus 6x plus 10 here, x minus 2 here. Box method, if you remember, you multiply these two and you got here inside is x cubed. Multiply these two and you got negative 6x squared. 6 times 10 is 10x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is going to be 12x, and then negative 20. Combine the like terms, which are these ones. So you write x cubed as it is. Negative 6, negative 2 is negative 8x squared. Then you're going to combine these two like terms, and that's going to give you plus 22x minus 20. So this is the polynomial we got, who has x value as 2, 3 plus I, and 3 minus I.